So we're here with one of my good friends, Andrew Eisenhower,
Howdy.
and we're going to ask him to explain in his own words trajectory.
So trajectory is the path that a projectile takes from its point of origin to an intended target. In the case of firearms, that would be from the muzzle to the target, the entire pathway that the bullet takes.
In your own words, how would you explain wind drift?
Wind drift would be a lateral motion, left and right movement of the bullet along its trajectory, provided there's a crosswind to that bullet in its flight path. Bullets don't weigh very much. You know, if you have a 223, you're looking at 55 grains, and if you have something in a bigger hunting caliber of like 30-06, you're looking at 165 grains. As far as grains to ounces are concerned, I think it's like 430 something grains to an ounce. So you're talking about a quarter of an ounce being pushed through the air very rapidly.
Yeah.
And any amount of wind is going to make that bullet go left to right.
Yeah. Recoil.
So when you fire a bullet, the rapid expansion of gas is what pushes that bullet through the barrel of the gun out the muzzle. But that expansion of gas, in physics, every action has an equal and opposite reaction. So as that bullet's pushing forward, there's gases pushing back against you, and that's what creates recoil. It's that kickback that you feel in the firearm once it's been fired.
Velocity.
Velocity is just the speed of the bullet. And there's muzzle velocity and there's downrange velocity. As it continues going through the air, friction is going to affect that bullet and it's going to slow it down. So it's good to have an understanding of your muzzle velocity, how fast it's going to be going as soon as it exits the muzzle, but also the course of 100 yards, 500 yards, so on and so forth, depending on how far you want to push out to.
Now, would that friction also count for Earth's gravity as well? Would that be one of the main factors?
In terms of velocity, not particularly. It'll definitely affect, gravity will affect how the bullet flies along its trajectory, right?
Okay.
So over 100 yards, it's not going to fall very fast.
Yeah.
But over 500 yards, if you have something like a 308, you might be getting 50, 51 inches of bullet drop.
Okay.
Over that distance.
And accuracy. How would, in your own words, define accuracy?
Well, there's accuracy and there's precision, right? So precision, if you were to shoot 3 rounds and you get them just right on top of each other, but not near where you were aiming at, that's precision shooting. But accuracy is trying to get those bullets as close to the intended target as possible. So if you can walk those 3-shot groupings down to that center ring right into the bulb,
And give me 2 examples of working through gunning calculations.
So I don't understand the majority gun calculations. I know that there's manufacturers that make apps for that. Hornady is one, and they have a full ballistics calculator, so you can input all the variables into it. What your muzzle velocity is, your scope to barrel distance, the bullet weight, your zero distance, and then whatever distance you want to push out to, and it's going to help you calculate if you have to aim up, if you have to aim down for it. But one of the examples that I can think of offhand would be in the military.
Okay.
Right? So in the Army with an M4 or M16, you zero that at 25 meters.
Yeah.
And the reason for that is because zeroing at 25 allows you to hit a 300-meter target without making any other adjustments,
Okay.
right? So when you do that, your barrel is actually slightly tilted up. It's not leveled out. But when you fire at 25 meters, it's going to hit that center ring. It's going to hit that bowl right where it needs to be.
Yeah.
When you start pushing out to 100 meters, you actually end up having to aim down on the target to be able to hit the target where you intended to because of that arc, because you're actually aiming up a little bit. In the course of 300 meters, it's going to reach its apogee, its peak, come back down, and land on that 300-meter target.
Okay.
So the further out you go, the less you have to aim down. You can kind of walk it up,
Okay.
right? And then the other thing would just be if you were a hunter with a Mildot scope, or if you were able to, on the fly, just kind of say, all right, I know this target is out 300 meters,
Mhm.
right? And you're looking through a Mildot scope, and I believe it's 3 inches per mil per 100 yards,
Okay.
right? So if you know your intended target's height,
Mhm.
and you know where your bullet is going to drop over the course of 300 yards, 400 yards, 500 yards,
Mhm.
you can use those mil dots to say, okay, I need to come up 6 inches. I'm in 100 yards. I'm going to go up 2 mil dots.
Now, part of those calculations, would you also consider the length of the barrel?
The length of the barrel is going to adjust your muzzle velocity.
Okay.
So absolutely, you need to do that. And I again, I don't remember offhand how many feet per second is affected when you lengthen or shorten the barrel,
Okay.
but it does take a part in that.
Okay.
You know, but the best thing you can do is put rounds down range and see where they go and
Yeah.
make adjustments off of that.
Okay.
You know, most people end up using what they call a dope card. It's data on prior engagement. So they're going to engage a target at 100 meters.
Mhm.
They're going to write down, okay, how did the bullet travel over
Okay.
100 meters? You know, did you set your 0 to 100 meters? If so, where's that bullet going to go when you fire 200 meters?
Mm.
Is it going to drop down further, or is it going to go up more?
Okay.
You know, and then based off of that, you can get your calculations. So that later on, you can say, all right, well, I zeroed at 200, but if I want to push to 500 yards,
Mhm.
you're looking at this big arc of drop,
Okay.
right? Because like I said, with a 308, you might be looking at 51 inches over
Mhm.
500 yards. 51 inches on your mil dot scope, each dot is going to represent about 15 inches. So you're
Mhm.
going to want to go up like 3 1/4 of those mil dots to
Mhm.
be able to hit your intended target,
Okay.
provided the wind is good and all that.
Yeah. So, how would you account for a scope that doesn't have those mil dots? Would you actually have to adjust the scope to?
If you want to be accurate, yeah, absolutely.
Okay.
You know, and modern rifle scopes, if you get there's 2 different kinds. One will be measured in 1/4 inch
Mm.
over 100 yards per click,
Mm.
and one of them will say 1/4 MOA, which is minute angle
Mm.
per 100 yards per click,
Okay.
right? And yeah, you could make that adjustment. It's just a lot of clicks to do,
Yeah.
you know. If you're doing a 1/4 inch over 500 yards, and you know it's dropping 50 inches, and you've got to come up 50 inches,
Mm. Yeah.
you're going to be spinning that dial a whole lot.
Yeah.
You know, but if you're a good enough shooter and you don't have a mil dot scope, you can eyeball it. Maybe not at 500, but if you're a little bit closer, absolutely.
Okay. Well, this was an interview with Andrew Eisenhower.